Chapter 27, Suspension Systems, Day 1, Video 2, Leaf Springs. So the diagram that we're looking at here is an illustration of a leaf spring suspension. So we've got the frame here, and we've got mounting brackets on either end that are supporting the end of that leaf spring. The leaf spring is the connection between the mounts that are mounted to the frame, and then where it's attached onto the axle, the steer axle in this case. So the leaf spring suspension, it's got multiple leaves. Okay, so the one going from end to end here, a flat, wide bar of spring steel. And then now this is a multi-layered leaf. So we've got another leaf underneath that one, and another, and another, and another. So 7 or 8 layers of these leaf springs that are joined together into a leaf pack, each one of them becoming gradually shorter and shorter as we go down, gives the weight carrying capacity of that leaf spring. So again, made of steel or spring steel, which is a heat treated steel that allows that leaf to bend a certain amount and not deform or break. So it's very specific type of steel that we use, again, the heat treated or tempered spring steel. When we combine those together, that controls the flex and the movement of that leaf spring. So the weight is put on the ends of the spring, and then the spring will start to deform and move, and now all these other supporting springs underneath here are helping to resist that movement of the spring. We can have a single leaf or multiple leaf pack. A couple of characteristics of the leaf spring, again, self-dampening. So we've got multiple layers of these leaves here with the surface area underneath here, and then another spring underneath, and another one, and another one. So we have a lot of surface area between the springs, so that as the weight is being put down on the end of the spring, there's a lot of friction resisting this spring from moving against the one below it, and so forth on down the pack. So that interleaf friction is very crucial to the way that the leaf spring works. We've got a center pin in the middle that holds that spring pack together, and then a U-bolt coming around the end here that attaches the spring to the axle. So that interleaf friction, or the resistance to movement, not only helps with its carrying capacity, but also causes what they call like self-dampening, right? It does not want to move. So when it does stretch and move and bend, we've got resistance, keep trying to force it from bending, and then once it is going to return back to its original shape, that surface area again is working against that movement to slow that suspension down. So we've got just the friction between the leaves, and then that center bolt, how tight that center bolt is tightened down when we manufacture the leaf springs, also determines that interleaf friction. So with that center bolt in the middle there holding everything together, that's an important part of the spring strength, and then all the friction resisting this leaf spring from moving at all. Shock absorbers in essence are not needed because we've got this friction between the leaf springs slowing that suspension down without the use of the shock absorber.